Welcome back to the channel. Understanding and correcting trim is a fundamental aspect of ship stability and safe operation. Trim is simply the difference between a ship's draft measured at the forward perpendicular and the draft measured at the aft perpendicular. If the forward draft is less than the aft draft, the ship is said to be trimmed by the stern, which is the most common and often preferred condition. If the forward draft is greater than the aft draft, the ship is trimmed by the bow, which can be dangerous, especially for large, full-bodied vessels. If the drafts are equal, the ship is said to be on an even keel. Trim affects nearly every aspect of a ship's performance. It influences fuel consumption, steering ability, and most importantly, stability. A ship's trim is changed by shifting weights on board, such as cargo, fuel, or ballast water. The key principle governing trim correction is the relationship between the center of gravity, G, of the ship and the center of flotation, F. When a weight is moved longitudinally, that is, along the ship's length, it creates a trimming moment. This moment is calculated by multiplying the weight moved by the distance it is moved. The ship rotates about its longitudinal center of flotation, LCF, which is the geometric center of the waterplane area. To calculate the resulting change in trim, naval architects use a critical hydrostatic property called the moment to change trim by 1 centimeter, MCTC. The MCTC is the trimming moment in ton meters required to change the ship's trim by exactly 1 centimeter. It's calculated for the current draft and is found in the ship's hydrostatic tables. The formula for the total change in trim is the trimming moment divided by the MCTC. So, to correct a ship's trim, the crew must first determine the current trim, decide on the desired trim, and calculate the required trimming moment. This moment is achieved by shifting a known weight over a calculated distance or by pumping a known amount of ballast water into or out of a specific fore or aft peak tank. For example, if a ship is trimmed too much by the stern, the crew might pump water from the aft peak tank to the forward peak tank, creating a moment that tends to lift the stern and push down the bow, thus reducing the trim by the stern. The process is constantly checked against the vessel's stability criteria to ensure that the final trim is both safe and efficient for the intended voyage. Accurate trim correction is vital for maintaining propulsive efficiency, ensuring the propeller is fully submerged, and keeping the forward visibility clear from the bridge. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.